In this session, we will discuss about the problems on transform, impedance and admittance circuit. We have gone through the theories of transformed impedance and transformed admittance circuit corresponding to resistors, inductors and capacitors. Now we will do a problem. In the circuit shown, the switch K is moved from the position 1 to the position 2 at a time t equal to 0. At time t equal to 0 minus, the current through inductor L is I0 and the voltage across the capacitor is V0. Find the transform current I of S. So circuit diagram is given and you can see R, L and C are there in the circuit diagram, and also there is a switch, and it is given in the question that at time t equal to 0, the switch K is moved from the position 1 to the position 2. That means at a time t equal to 0, the switch will move from this position, that is this arrow mark will move from this position to this position. So this circuit will be connected to V1 of t, then R, L, C at a time t equal to 0. And at a t equal to 0 minus, the current through the inductor L is I0 and the voltage across the capacitor is V0. That is also marked at a time t equal to 0 minus, that is before the time connecting to the second position of the switch. The initial condition of the inductor is I0, that is current flowing through the inductor is I0 and the current voltage across the capacitor is V0. That means the capacitor will charge it to a voltage V0. So these are the conditions given in the question, but you are asked to find the transform current I of S. What is the transform current here? It is given that time domain current is I of t. You are asked to find the transform current I of S. So you are asked to find the transform current I of S. First of all, you have to draw the transformed circuit, transformed S domain circuit of this figure. See, here you have to draw the transformed S domain circuit when this switch is connected to the position 2. So there will be a resistor, inductor and capacitor, but we know that when an inductor is transformed, it contains a series combination of a voltage source and an impedance. Similarly, when a capacitor is transformed in S domain, you can see that it will be a series combination of a voltage source and an impedance. So you can draw the circuit. See, this is a circuit shown in the question, and at time t equal to 0, the switch will be connecting to the V1 of t. So we can draw this portion of the circuit alone. This will be ejected because there is no connection with the point 1. So first V1 of t, we will draw the, we are going to draw the transformed circuit. So instead of time domain, we will transform it into S domain. So instead of V1 of t, it will come V1 of S. Since it is a voltage source, that voltage source is marked first. Next is the resistance. You know the resistance. In the case of resistance, the impedance is denoted by ZR and its value will be R itself. So we can draw the ZR like this, the resistance symbol. Next, there is an inductor, and you know that in the case of inductor, when it is transformed into S domain, we can draw it as a series combination of a voltage source whose value is L into I0, and also it is drawn by an impedance value Ls. So we can draw a voltage source L into I0. This is the voltage due to the initial current through the inductor. So its value is L into I0. So its symbol is from minus to plus. And next we can draw the inductor having the impedance value L into S. Actually these values are obtained from the analysis portion of the inductor at transform impedance circuit. So L into I0 into Ls comes instead of inductor. Next we will see capacitor. It has an initial voltage V0 and the capacitor can be drawn as a series combination of another voltage source. Its value is V0 by S and impedance value as 1 by Cs. So its symbol is plus minus and impedance value is 1 by Cs, and the current through this circuit is I of S. This is a transformed current and you are asked to find out this current I of S. So this is the transformed circuit. So for finding the transformed value of current, first of all you have to know how to draw the transformed circuit. So you just remember the transformed circuit corresponding to the inductor, and also remember the transformed circuit corresponding to the capacitor. That is the only thing that we needed here. The corresponding to inductor, the transformed circuit portion is this, and corresponding to capacitor transformed circuit is this. So in this circuit, you know that you are asked to find out the value of I of S. You know that I of S will be equal to total voltage divided by total impedance, right? So total voltage is here V1 of S plus this is another voltage source, and this is another voltage source. So you can add all these voltages. Therefore V1 of S, since its sign is coming from minus to plus, so plus Li0. But here its sign is from plus to minus, so it is a negative sign, that is minus V0 by S. Therefore total voltage is equal to V1 of S plus Li0 minus V0 of S divided by total impedance is R plus Ls plus 1 by Cs. So at the denominator R plus Ls plus 1 by Cs comes. So we can rearrange this equation and we will get the form as S into V1 of S plus S into Li0 minus V0 divided by S into R plus L into S square plus 1 by C. So this is the transformed value of the current I of S. Next we will do another problem. The network shown in figure 15-16 is a parallel combination of L, R and C connected across a current source I. At a time t equal to 0 minus, the current through the inductor L is I0. And the voltage across the capacitor C is V0. At a time t equal to 0 plus, the current source I1 of t is connected to the parallel RLC circuit. Find the transform voltage V of S. So this is the circuit diagram. There are different current sources I and I1 of t. It is given that before time t equal to 0, that is at t equal to 0 minus, the switch is connected to this position 1. And after that time, that is time is equal to 0 plus, the switch is connected to position 2. You are asked to find out the transform voltage V of S. You are asked to find the transform voltage V of S, and here first of all, in order to find the transformed quantity, you have to convert this circuit into transformed circuit. For that you have to draw the S-domain equivalent circuit for this circuit. So for that, you know that at t equal to 0 plus, the switch is connected to the position 2. So we have to draw the portion when it is connected to I1 of t, and this portion will be ejected out because there is no connection with the point 1. So correspondingly we can draw it. This is not included in the circuit portion. Instead I1 of t is connected to the switch at t equal to 0 plus. Therefore instead of I1 of t, we have the transformed value I1 of S. Next there is a resistor, inductor and capacitor. These are connected in parallel. So it is better to use the transformed admittance circuit in the case of parallel circuit. So the transformed admittance value for the resistance is G, that is conductance. G is connected here. Next is the inductor L, and this is, since this is a parallel circuit, we can use the parallel equivalent transformed equivalent circuit for this inductor. You know that the parallel circuit contains the current source I0 by S and 1 by Ls. So inductor is replaced by the parallel combination of these two. Similarly, next is a capacitor, and a capacitor can be replaced by the parallel combination of a current source and another admittance CS. So instead of C, we are drawing parallel combination of CV0 and CS. You should take care in drawing the direction of current source. See, in the case of inductor, it is in the downward direction. In the case of capacitor, it is in the upward direction. And these symbols are purely based on the theory portion of the capacitor transformed circuit and inductor transformed circuit. So you should go through the theory portion or theory portion of this capacitor transformed circuit and inductor transformed circuit before doing this problem. Okay. So these are then we will get the corresponding equivalent circuit for this circuit. Okay. Once we get this circuit, we are asked to find out the transformed voltage. We know that transformed voltage is equal to the transformed current into total impedance, and here we are drawing the parallel circuit. So we are using admittance. So instead of resistance we can use admittance. So the transformed voltage will be equal to the V of S will be equal to I of S divided by Y of S. So instead of I of S, we know that the transformed current, here there are different current sources. So transformed current, total current will be equal to I1 of S flowing up and I0 by S flowing down and CV0 flowing up. So the upward currents are added and downward current is subtracted. So we will get I1 of S plus CV0 minus I0 of S. So total current is I1 of S minus I0 by S plus CV0. And the impedance, total impedance is G 1 by Ls and Cs, and these all are added. So total impedance is G plus 1 by Ls plus Cs. So we will get the transformed voltage V of S is equal to I of S by Y of S, and we can take the ratio. So we will get the V of S. So you can see, when we are getting the transformed equivalent circuit, it is very easy to solve the problem by using the basic Ohm's law, right? That's all about this topic. Thank you.